Now for the last part of today's lesson, which is the triangle midsegment theorem. Now first, it would be helpful to know what is a midsegment. A midsegment of a triangle is a segment that connects the midpoints of two sides. So in this case, it would be this piece right here. See how D is a midpoint and E is a midpoint? Well, whatever segment connects those two midpoints, that's called a midsegment. An interesting thing about midsegments is that they are parallel to the other side that they're not intersecting, and the length of this segment, DE, will be half of the length of AB. And I can actually prove the parallel part to you now. So I'm going to prove that DE and AB are parallel. First of all, I have these coordinates x1, y1, x2, y2, and x3, y3. I'm trying to show it's true for the general case. So this is going to be a little algebra heavy, but you can make it. So first of all, I'm doing the slope of A to B. So that would be y3 minus y1 over x3 minus x1. I know you're used to x2 and y2, but I've got those on another point, so I can't really use them. So it's the second y coordinate minus the first over the second x coordinate minus the first. So that's based on the definition of slope or the slope formula. Then I'm going to find the midpoint D. Well, the way you find the midpoint is you average the 2 points. In fact, this looks like the formula straight off of your math chart. That is the midpoint formula. Well, the point for E is going to look just a little bit different because its first point isn't x1 and y1. It's halfway between x2, y2, and x3, y3. So the x2 is now here, and my x3 is in the old x2 position. So that might feel a little confusing, but that is the midpoint formula. Okay, the next part is I'm going to find the slope, and this is going to look a little scary. All right, so I say this y-coordinate minus that y-coordinate, there it is, over that x-coordinate minus that x-coordinate. Okay, so that's the slope formula. Now here's where it gets really interesting. I'm going to go ahead and combine these two numerators. So I'm going to have to subtract y1 and y2 and put the whole thing over 2. And I'm going to subtract this x1 and x2 and put that whole thing over 2, which gives me this. Now I went ahead and put in a 2 over 1 on both of these because these 2's are driving me nuts. And what I'm going to do is go ahead and add a common term. So I have y2 and minus y2, so those two cancel out. Same thing with x2 and minus x2. The reason I put in this 2 over 1 is so I could cancel out these 2's and cancel out or simplify those 2's. So when everything's said and done, I end up with just that, which means the slope of DE is y3 minus y1 over x3 minus x1 after I simplify everything. So that's based, all of this was multiplication property of equality. And since I have two segments with the same slope, by the parallel lines theorem, if the slopes are the same, the lines are parallel. So we just proved that the midsegment DE is going to be parallel to the segment AB. So how are we going to use this in problems? You're not normally going to have to do proofs, especially proofs that complicated. You're going to be setting up equations. Basically, you have to know the midsegment is half of the base. And you're going to use either the midsegment equals the base divided by 2, or what might be easier is the base is 2 midsegments long. Now, you can also find angles by using angle pair relationships from parallel lines. We just showed that the midsegment is parallel to the base. So if I can use like alternate interior, corresponding, same side interior, all of those angle relationships will hold. In this example, I know the midsegment has length 2x minus 1 and the base has length 3x plus 5. So I'm going to use the easier setup, which is 2 times the midsegment equals the base. So 2 times 2x minus 1 equals 3x plus 5. Use the distributive property, 2 times 2x and 2 times the negative 1. So I get 4x minus 2 equals 3x plus 5. Subtract 3x from both sides, and I get x minus 2 equals 5. Add 2 to both sides, and x is 7. Well, I'm not done. I was actually looking for the length of DE and the length of BC. DE is 2x minus 1, so I substitute in the x, which is 7, 2 times 7 minus 1 is 14 minus 1, or 13. I do the same thing for BC, which is 3x plus 5. So it's 3 times 7 plus 5, 21 plus 5, or 26. And that's good, because DE, you can see, is 13. The base is 26. The midsegment should be half of the base. So this makes sense. Now we're going to look at some angles created by midsegments. So first of all, I know the measure of angle A is 52 degrees. I know the measure of angle C is 73 degrees. I'm trying to find the measure of angle AED, which is right here, and EDB. Well, first of all, for AED, I know that this angle right here is going to match angle C here. The reason is, if these two lines are parallel, you can see the transversal here. These two are corresponding angles. So AED is 73. Now I'm going to use the triangle to figure out what this angle is right here using the triangle sum theorem, that this 52, 73, and this mystery angle should equal 180. So I'm calling that angle measure of angle B. Then I combine like terms, subtract 25 from both sides, and I get the measure of angle B is 55 degrees. All right, so now I'm trying to find EDB. So why did I want to know that one? Well, I could, you can see that angle 55 here and this angle are going to be related because I have parallel lines right there. So here's my transversal this time. I'm trying to find the green line, and you can see the two parallel lines. So by same side interior angle theorem, I know that this angle and 55 are supplementary. They have to add up to 180. Substitute in the 55, subtract it from both sides, and I get that this angle is 125 degrees. So for further reflection, think about, why is a midsegment always parallel to one side of a triangle? And how do you set up equations for midsegment problems? What is the relationship between a midsegment and its base?